Learn the lighting basics with this Ray for Rhino tutorial. Let's start with an interior model, with furniture and windows. The next major step is to place lights in the scene. The reason to implement the lights before adding material is simple. With good lighting, the materials will fall into their own. Once the lighting is set correctly, you will then have a realistic feeling for what the materials are doing and how they react to subtle changes. Let's add an exterior light to simulate the sun coming in from each window. To do so, I use the Sun tool that comes with Ray for Rhino. This allows the user to have advanced control over the exact sun angle given a particular time of day and geographic location, or you can manually place the angle of the sun if specifics aren't important. The exact location that the sun is placed in the scene doesn't matter at all because, like in the real world, the sun shoots an infinite number of rays in a parallel direction to each other throughout the entire scene. It should be noted that this sun lighting system works only when using the Ray physical camera in the camera settings. The next step is to add rectangular lights at the openings to supplement the sunlight system. This helps to create additional light as well as add a bit of realism to the scene by focusing more light at the openings, a phenomena that also occurs in nature. To do so, create a rectangular light that is slightly larger than the opening, ensuring that the light is pointing into the room. To manipulate the lighting settings for the rectangular lights, select the Light and in the Properties tab, select the roll down and change it from Object to Light. The multiplier value for these rectangular lights will depend on a few factors, camera settings, and size of the light mostly, but a few things to keep in mind, that you should select Light Portal. This tells the program that it is to be used to supplement the existing light from the exterior, similar to the way a light comes into a window. We also want to ensure that the light is invisible, so we can see through it and see the exterior of our scene. In this case, we don't need to have the light be double-sided because we are only interested in focusing the light's energy to the interior of the scene. Visible light versus invisible light source. Notice the intensity doesn't change. One-sided light source versus double-sided. Below is the settings that I used for this scene, but note that your values may need to change depending on your particular scene. To ensure that I'm not getting any material interference, I have added a neutral material to the material override in the Ray option settings. In this case, I check the Override Material box under the Global Switches tab. Override material with color over 128-128-128, a medium gray. In order to allow the light to come through the openings, I must hide the windows in the Rhino model, even if we've added a glass material to the windows because the material override will override all materials including the glass. This seems like a good time to do a test render, but first we must look at some of the other rendering settings in our render options. The first tab that we should focus on is the Global Switches tab. We want to ensure that lighting is checked, letting the program know that it needs to calculate the lighting. We however don't want to have the Hidden Lights box checked because if we hid some lights in the scene, we shouldn't have those calculate, we just want to see the effect of the lights that are shown in our scene. We also don't want to select the Default Lights box because we have placed lights in our scene and want to use only the lights that we have placed and have control over. The next tab in our options that we should be concerned with is the Camera tab. Because we are using the sunlight system, we should ensure that the physical camera box is selected. If we forget to check this box, the scene will be way too bright because we are not allowing the calculations to compensate for the incredible intensity from the sun. For those who have used a digital SLR camera or a film camera should quickly recognize the controls over the physical camera. Here you have the ability to control the camera's shutter speed, the f-stop number, and the film speed. These three numbers work in conjunction with each other to create how the camera compensates for the exposure of the lighting. This may take some time to get comfortable with if you have never used a SLR camera before, but the Ray manual has a very thorough explanation of how each of these controls works. It can be found at asgvis.com under the Software and Support tab. The Output tab allows a user to override the size of the image that they wish to output. If, for example, I know that I need an image that is 1500 pixels by 800 pixels, This is the place to input that information. It also allows a user to obtain the aspect ratio from the existing scene for easy scaling, by first selecting the Get View aspect, locking the ratio, and then changing the pixel size. This is useful if a user wants to ensure what they see on the screen is what is rendered for a given size. If I set up my scene and like how it looks on my screen, I'll use this technique and then tell the program that I need a maximum of, for example, 1500 pixels wide. However, if I'm simply doing test renders, the output size isn't an issue yet. The Environment tab gives the user the ability to create the environmental lighting, not the direct sunlight, but the light from the sky, and control how it is handled in the scene. Because we have created a sunlight system, it's possible to link the position of the sunlight to the environmental light. By linking the two, we will get a reddish light as the sun approaches the horizon, as occurs in nature. As the light comes closer to noon, the environmental light will become more bluish. To link the sunlight position to the environmental lighting, select the little M next to the GI, Skylight, checkbox. When this is selected, a new map texture editor pop-up will appear. Change the type from None to Sky. Before selecting Apply, we must make sure that the program knows which light source we want the sun to be. Select the button next to Sunlight Source. A new pop-up menu appears and now allows us to select the sunlight we previously created. If we leave this at default, we will not create a link between the sunlight and the environmental light. Once we select the proper light, click Apply, to get back to the Gray texture editor. Make sure that you unselect the checkbox next to Override Sun's parameters and finally click Apply. We have now created a link between the light from the environment, in this case the sky, and the sun's position in the sky. The next option in the Environment tab is the background. We can follow the same process that we just went through to add a background that matches the sun's position in the sky, or we can add a background image if we have a JPEG that we want to use as a background. This can be helpful if we have a site photo, a stock image of a nice sky with some clouds, etc. Since I am creating an imaginary scene, I'm going to apply the link to the sun's position as previously mentioned, following the same processes. At the end of this process, your Environment tab should look similar to that below. The next tab we'll talk about is the Indirect Illumination tab. First, ensure that the box under GI is turned on. This allows the light waves to bounce off of geometry and give reflected light, ensuring that light bounces off the floor and continues to bounce and light the scene. If this isn't turned on, the only thing we will see in our scene is the direct light from our light sources, which will cause a very harsh and yucky, yes, that's a technical term, lighting results. Next we get to select what types of rendering engines we will use. These deal with the way that the program calculates how the light reacts in our scene. Some teams way smarter than I am created various algorithms for how light reacts, and that's essentially what we will be selecting. I won't go into the boring details of each one right now, but I will tell you that I use the Irradiance map, IR map, as the primary engine and the Light Cache, LC, as the secondary engine. I have found that these two in combination give me the best quality and the lowest render time. For test renders I use the following value under my IR map tab. In the next tutorial I will further explain what these mean and how to control quality output. And the following are the typical LC settings I use for test renders. Please note, depending on the scene, the subdivs can be between 100, quicker, less accurate, and 500 for tests. We can now run a quick test render to ensure that our exterior lighting is working correctly, and with the short render time we get decent results. It's a bit grainy, but we will take care of that later. At this point, we are strictly focusing on the lighting. Notice the bluish tint that we are getting on the floor close to the windows as a result of linking the environmental lighting to the sun's position. This is what we might expect in nature. Test quality rendering, exterior lights only, 16.6 second render time. We can now continue adding lights to our scene. In the wall sconces, I prefer to add double-sided rectangular lights because 1. They are faster at render time. 2. That's the way the light actually comes out of a sconce like this, primarily from the top and bottom. Yes, I know the shade will glow, but we'll take care of that in the next lesson when we talk about materials. Finally, because there is a door opening and I want to add a bit of life to the scene, I add a rectangular light at the ceiling level of the adjacent room, giving a slight amount of light added to the room that our scene is focused on. When all is said and done, we have the images as shown. Test quality rendering, all lights, 27-second render time. Visit garagefarm.net today and render your V-Ray for Rhino projects with ease. Get $50 trial credits to test the Ray for Rhino Render Farm service with all features enabled without any commitment.